We've come to this very beautiful time of discussing operators, so let's define an operator first before we move any further. This is a construct in the programming language that an operator performs sort of operation on the operands. Operands are values. And it also returns a value as well as the result of this operation. And depending on what kind of data it receives, it's going to produce a different result. It's going to behave differently. So for instance, if we try adding two numbers together, the result, as we've seen already a couple of times before, it's going to be 4, as in the mathematical sense. If, however, we try adding two strings together, it's going to concatenate them. It's going to put them together and it's going to produce another string, just longer, 2 and 2 together. And one very important thing is that JS is a weakly typed language. What does it mean for us? It has consequences. The JS is going to help us. If we try adding to the string and to the number, it's going to change the type of the number into a string, and it's going to produce exactly the same result as putting two strings together, because underneath it's going to change the number implicitly. So we don't see it, we don't have to do anything, it's just happening. It's beyond our control, but we have to be aware of that mechanism that this is going to happen. That's 2 and 2 is going to be 2 and 2 as a string and not going to be changed into a number. So whenever we create a variable, we do not specify exactly what kind of data is to be stored in that variable, meaning that value type is defined by like the context sort of. So even though this is a number and this is a string, if we try performing an operation on this, the JS engine will try helping us and actually not throw an error but produce something else. So we have to be aware of that mechanism that this is happening underneath. And for instance, if we try adding a number and the logical value of true in JS evaluates to 1. So it's like, again, in the mathematical sense, it's going to result in giving us 3 because it's 2 plus 1. However, if we try adding a string and a logical value of true, this true is going to become a string for that moment, and it's going to produce a string concatenating those two. One interesting thing is that it doesn't really matter where you're going to put that string, if it's first or in the second position. It's not like if the number was first, then the second type would be converted into a number. It's still going to be converted into a string and it's going to produce the same result, so 22 as a string. But any other arithmetic operation, so anything else but the addition operator, this is going to behave differently. So all this is going to be changed into number. So these are the quirks of JavaScript. Operator can be anything. It can be a character or it can be a word, and we got familiarized with the type of already. It can be delete or a new. So type of 1200, it's gonna return number as a string. So it's gonna inform us about the type of the value of the given value of whatever we put here. We could divide operators by the number of arguments. So I've declared my variable result here for the purposes of this presentation. So for instance, the assignment operator works on 2 arguments. So there's a variable result and it's got its assigned value of 1. So we've got 2 operands. These are 2 operands and the assignment operator in the middle. Increment operator has only 1 argument, it works on the same variable here, and it's got 2 pluses, meaning that we want to add 1 to it. Let's just send. We also have the ternary operator, but it's only going to be shown at the very end because we have loads of mini things to go through and this is slightly more complicated, so let's not confuse you just yet. Let's wait for the end. So got arithmetic operators. Got that variable here, position, with the value of 2. If I now uncomment this, save it, it's gonna print out 2 in console because this is the value that position is storing at the moment. I want to show you an incrementation by 1, so adding 1 to any value that is currently storing is going to add 1. Those 2 pluses always adding 1, increased value by 1. And if I do this, what will you see on the screen is 2. But if I check the value of position now, it's 3. So basically, it works this way, that it first prints out whatever the value is at this very moment, and later on increasing the value by 1. So it is storing 3 now, but it's going to print out 2. Kind of confusing. But we also have pre-increment. So it's spelled differently. It's spelled with 2 pluses at the beginning and the variable name later on. And it works exactly the same way, except for one thing, that it's going to print out the result. So first add the number, increase by 1, and then print out this result in the console. So it's going to print out 4 straight away. Let's check what is the value of position now. It is 4. So it is 4 and it's 4 in here, but it's slightly different when you do this. Okay. Decrementation works exactly the same, just the other way around. So if I do position minus minus, it's going to print out 2. I've reset the value to 2. So the position is storing 2. I do the decrementation here. It's going to print out 2, but the value of the position should be minus 1 now. So it's storing value of 1. And we have this pre-decrementation. And if I do minus minus first and then the name of our variable, it's going to print out 0 straight away, and it's going to store the value of 0. So it's something that you kind of have to learn as well to not get surprised later on. Assignment. That's an interesting way of writing down. The position here is the same position from here. Clear the console and good. Let's check the value of position now. It's 0. Okay. let's refresh the page. Let's go back to 2. Cool. So console log here position is telling me that the value of position, the starting point is 2. So everything has been reset. It's storing the value of 2. And from here, we are moving on to this notation. This is exactly as if I said take position and assign a new value, position, and add 10 to it. So this and this, oh, actually it's already here. So this and this and this, these are exactly the same things. So this is just shorter way of saying that I want to add 10 to wherever it was before. So if currently position is storing a value of 2, if I paste this in here, it's going to now store value of 12 because it's taken the position from here, so 2, whatever the value is storing, and adding 10 to it. And this is longer way of putting this, and this is a shorter way. And the same goes for any other arithmetic operation. So if we want to minus something or multiply this by a number or make a division, it's always going to be the same. It's just different character in here. So let's copy this. And this position minus equal 16 is exactly as if I was saying take position, whatever the value is stored now, and from that value subtract 16. This and this is a different way of saying the same thing. For some time there, I've kept on putting equal mark first and then the minus, because I just couldn't get my head around this concept. And I was just, my head was like not getting it. Why? Well, I understood the notation, I just kept on insisting that the equal mark should go first, but maybe because here the equal mark is first and then the minus, but it's not. First minus and then equal mark. Cool. So the same goes for here. Let's refresh the page. So my position is storing the value of 2 at the moment. And here, if you understood the concept, what should be done on here is that position is 2, meaning I want to do 2 times 4.2. So the result should be 8.4. And it's 8.4. And it's exactly as if I said take position and multiply by 4.2. Okay, this is exactly the same thing. And it goes on and on and on with any other arithmetic operator. The same way, we don't have to only treat numbers, but we can take another variable. So for instance, here I've created a new position with the value of 0. And now I want to assign a new value to my new position. And this notation here means nothing but take, I'm just going to write in here, take whatever the value of was of new position, in our case it's 0, and add whatever the value is of the position. So this equals this. So currently new position is holding 0 and position is holding 2 because I've console logged this value here. So it should print out 2. Let's uncomment the console log and let's check. Right, so we've added 0 to 2, and now both position and new position are storing the same value of 2. And if this isn't exactly clear, and you'd have to like type it yourself, and not once but a couple of times, and with different examples, and it's going to become very clear very soon. And we should move on to the next thing, which is a modulo. Modulo is also a very interesting concept because it's a remainder from the division. So for instance, 10 modulo 9 would return 1. And why is that? It's because if you try dividing 10 by 9, only 1 9 is going to be fitting into the 10, and the remainder from the value is 1. If you try doing 7 modulo 3, you can fit 2 3s into a 7, and the remainder from that sum is also 1. If you try doing 8 modulo 3, the remainder is 2. And if you do 9 modulo 3, the remaining sum is 0. Nothing remains. So all 3 times 3 is 9. So there's nothing left for us. We use this example from here. Also 0 because 4 fits into 20 5 times and there is nothing left. And modulo is very often used in validation for like even and uneven numbers, whether the remainder is going to be 1. So we know that we're dealing with an uneven number, and if the remainder is 2, then we know that we are dealing with an even number. And it's used so very often. Also something for you to play with, and before you understand fully, I think you should put loads of different numbers inside because you can be surprised about of the result. Double star is an exponentiation operator, difficult word, and it just simply means to the power of. So 2 to the power of 5, meaning 2 times 2 times 2 times 2 times 2, 5 times. This is 32. 3 times 3 times 3 because it's 3 to the power of 3. 3 times 3 is 9 times 3, 27. So those mathematical operations also possible. You can use it as a calculator. Logical operator, comparison operator greater than or less than returns true or false. So this is pretty obvious. but it's for you to practice the operator. So is 20 greater than 40? No, obviously it isn't, so it's going to return false. Surely. Yes. If I put something like this, you should already be able to tell me what this means and what it should evaluate to. So this is a simple data type, and we can get inside its property straight away rather than creating a variable, declaring it, initializing with the value of text. We can right away get inside its property. So the property of length is how many characters are in the string. So here I've got 1, 2, 3, 4. So is 4 greater than 3? It is, and so it should return true. This notation here means less than or equal to. So is 20 less than or equal to 20? Is equal, so it will evaluate to true. Comparison operator, meaning are these the same? Are these equal? And here I've got double equal mark, which allows for conversions. So let's just start simple. Got text and text too, so we can see straight away with our own eyes that these are not the same because those two strings are slightly different. So this will evaluate to false. But the concept is that with two equal marks, I'm trying to check if those two values are the same or equal. So these are not the same, these are different, and so it evaluates to false. Same will go for two different numbers because these are two different numbers. 2 is not equal to 2.2, so it's false. However, here the conversion is happening, so the program doesn't care that one is a string and the other type is a number, and it would evaluate this expression to true. So it would convert the string into a number, and so basically it compares two numbers now. 2 as a string, here in this case it's converted into a number. And so since they are the same and the conversion is happening implicitly underneath without us doing anything, it would evaluate to true. Well, we also have a strict comparison operator, which is marked by triple equal marks. So if we try comparing 2 as a string and 2 as a number with a strict comparison operator, it will no longer evaluate to true because it's gonna check for type and for the value, and the conversion isn't allowed in this case. So this is now false. Got operator different from, and it's marked by the exclamation mark and an equal sign. So it's like kind of the opposite of what we are doing here. Here we're checking if these are equal, and here we are checking if they are different. So 100 is different from 101, so it's going to give us the result of true. It's going to return true. What do you think should happen here, even though I've already put the answer? So this is 100 as a string, this is 100 as a number. Are these equal? Yes, these are equal if we don't do the strict comparison. So, since they're equal, because the type string is converted into number, when we do the opposite, so are we asking if they are different, these would evaluate to false. So like everything is opposite to double equal mark. And here we have this different from, but as a strict comparison. So got 100 as a string and 100 as a number. And so if we tried the strict comparison, it would evaluate to false because the conversion is not happening. So it's checking, oh, this is a string, this is a number. So these are not the same things, but because we are checking if they're different, so it would say, yeah, these are different. I have another interesting concept in JavaScript, which is a logical negative. It's a negation, and this exclamation mark here is as if we said not. So the exclamation mark is turning everything around. So it does two things. It will convert the value to Boolean type, and then invert the value. If it was true, then false, and if it was false, then it would become true. So string evaluates to a truthy value. So that first step converts to Boolean. Since it's not an empty string, this is now true. So this is the same as if we said here, true. And then because this is as if we said not, then it's going to evaluate to false. Let's paste it in the console. And so it is false. True becomes false, false becomes true. And that's the result of the logical negation. 2 minus 2 evaluates to 0. 0 is a falsy value. And since this is the opposite, this should evaluate to true. So you can see we also have a double negation. So basically it does the same thing that it does the first one, but then goes one step further, negating the negation. So basically it's as if it's just turning the value that it receives into a Boolean type. So it would return the logical value. So if 200 is truthy value, then it would return true. If we wanted to check whether something is true or false, this is a very quick way of doing this. So just 2 exclamation marks and the value that we want to check. Whoa, we're already at the end. Logical sum. Logical. If at least one operand returns true, the expression can be considered true. However, to understand it well, we need to know the return value mechanism. Well, I need to paste some more text in here clearly I've missed something. I'm coming back in just a second. Okay, another thing that we have to discuss talking about operators is the logical OR. If at least one operand returns true when we do this, those two characters make up OR in JS. If at least one of those is true, if at least one operand is true, the entire expression will evaluate to true. So true or false returns true because there's at least one true. False or true, at least one operand is true. So again, this would return true. True or true definitely returns true. But if this true, false or false, then the result of this expression would be false. And so I'm going to explain a kind of abstract thing. I'll do it again when we talk about booleans, so to make sure that you understand correctly. But then if I have this expression and I'm going to paste it in here into the console, it's not going to return either true or false, even though it evaluates what value, whether it's true or a falsy value, what kind of type is the operand. So it can see that it's 2 on the left hand side and a 0 on the right hand side. And because it's OR, it needs only one value to be true for this entire statement to be true. And it kind of enters this expression and can see that, okay, I've got 2 on the left hand side here and it's true. So it doesn't move any further and it's just going to print out whatever it found on the left hand side. So it doesn't return true or false. If we paste another example, 0 or null, both values are false in this case. So similar as in the above example, it checks from the left and it can see 0, so this is falsy value. But because in this kind of expression using OR, logical OR, only one value has to be true for the entire thing to be true. So it goes on and checks the other value just to make sure maybe the other one would be true and then the entire thing would be true, but it isn't. So it prints out the last thing it found. So it's going to be null. If it was 0 or 2, it would print out 2 because it again went on, so 0, so it's faulty value. Let's check the other one. Maybe the other one is true, so for the entire thing to be true, and it found 2 and it's going to produce 2. It's so very abstract that you just have to trust me and have to understand that. Try to understand that that's how it works. We've got also a logical and for the expressions with logical and, both operands have to be true for the entire statement to evaluate to true. So for instance, true and false is false. So true and false. The first condition is true, so the operator passes to the second condition and returns false because it didn't pass. The entire statement evaluates to false, and it returns whatever it found on the second position. It's pretty much the same as with the logical operator OR. So if we have 200 and 0, 200 is converted to true because this number is truthy, is true. 0 is false. So it checks 200, but the entire thing has to be true. So both operands have to be true for the entire statement to be true. So it checks. This checks out. 200 is okay because it's true, but 0 isn't. 0 evaluates to false. So let's paste it in the console. It's not gonna print out false as in this case because this is just printing whatever it found on the second position. So it's gonna print out 0. It evaluates its value, the logical value. So 200 is true and 0 is false, but it's not gonna print out false. It's gonna print out 0 because that's what's found on the second position. If it's gonna pass the condition, so both values are true, again, it's gonna print out whatever it found on the second position. So it checks the first one, okay, this is true, but for the entire statement, including the consisting of the logical AND, both values have to evaluate to true for the entire statement to be true. And this one checks out as well because it's true, and it's going to print it out to the console. If we take this one in here, so 1 is a true value, but empty string isn't, and so it doesn't pass the condition, but it's also going to print out the second element to the console. And this is the entire expression. So is 20 greater than 10? It is, so this one evaluates to true. And is 10 less than 20? This is also true. So what do you think should happen in this case? This is the expression that things will be evaluated to true or false, and it's going to print out true because this result of this is true. This evaluates to a logical value. And again, if this isn't clear, you'll have to come and do many examples by yourself. Just paste it and see how it works, because the mechanism is for you to be learned by yourself, and later on in the actual exercise I can present and show you how it can be used in the real life scenario. But whatever is going to be printed into the console, this is something you would have to work like after class, that the logical operator AND needs both values to be true for the entire statement to be true. And so it's going to, even though the first value is true, it will go on and check the other one to make sure that it is true. And for the OR operator, the first one is enough because only one operand has to be true for the entire statement to be true. So it won't go on and check the second element, and it's going to print out 2 straight away. This is something for you to work on and get it right yourself. This is like this logical stuff. Order of operators is pretty simple because it's the same as in the class. That's cool. So basically the multiplication will be done before the addition operator. So 3 times 5 is 15 plus 2 is 17. And if we use parentheses, this will also take precedence over. So even though there is a multiplication that normally would be done first, 3 times 5 and the rest later on, but it's because of those parentheses around, it'll be 2 plus 3 equals 5, 5 minus 4 equals 1, so 5 times 1 equals 5. Conditional operator. So that's the one that I talked about at the very beginning, but I said that I'm only going to show it at the very end, not to confuse you. So this is an operator that will take 3 arguments. It's a ternary operator, and it's only for the curiosity, just as a kind of like, well, it's not a fun fact. It's something that is actually very useful in the everyday life of a developer. But then we have expression. An expression evaluates either to true or false. So in this case, it's very simple, but it's only for the practice purposes. So if is 3 greater than 2, it is true. Then goes the question mark. And then if this entire statement would evaluate to true, the first thing would be executed. And it doesn't have to be a string. It can be a function, it can be an instruction, you can instruct the program to do something. And if this condition hasn't been met, so this would evaluate to false, so the second argument would be executed. So it's like in the first very simple program. Is 3 greater than 2? Yes, it is. So the program answers the question. Cool. So again, I would like you to practice this a bit by yourself. Go through the notes. The most important for today is that for you to remember that this is an OR, logical OR operator, and double ampersand is a logical AND, and when both are true, the entire statement would evaluate to true. Both have to be true. Even if one is true and the other one is false, the entire statement goes to trash. Which isn't the case with the logical OR operator. Only one value has to be true for the entire statement to be true. Most important for today, for this class to remember. Yeah, well, and I'll see you talking about string or number next. Cool, so before we move on and talk about string, number, and Boolean data types, I think it would be good for us to discuss literals, mention properties, and methods, so that the topics later on will be easier to understand. Okay, so what are literals? Literals are like set of characters that would be used to communicate with the interpreter so that the program knows what kind of data type we intend to create. So for instance here, got a set of characters in quotation marks, here marked by the double quotation marks, and it doesn't matter if you use double or single like in here, or backticks. These are all going to be recognized by the interpreter that we wanted to create a value of type string. If we put numbers, any number, then the program will know that this is a number type and it's not wrapped by any other character. It's just a number. Similar thing for a flag, true or false. If you put that, it's a reserved word and it's going to be also recognized as Boolean. Null and undefined, same thing. Slightly different for the symbol, which is not created with the literal, but is not going to be discussed here. So it doesn't really matter. And not only simple data types, but also objects are also like created using literals. And the object literal is curly braces. And if you wanted to create an empty array, you would use square bracket. So in here, it could contain some value inside, but for now, if you wanted to create an empty array, and all these is going to be discussed in detail later on, but for now, just for you to know how you use literals and what they are. So these are a set of characters recognized by the interpreter, and thus we can communicate and inform what kind of data type we intend to create. So now I'm going to say something that is pretty obvious, or should be already, that simple types are not objects. But we can perform methods on them and we can access their properties, even though this is like a characteristic of objects. So some say that everything in JS is a object. But this is not entirely true. Simple types are just simple types. So this is a string and nothing else. This is a number and nothing more. And there is a certain mechanism, and this is something that I'm just kind of going to take you out of your comfort zone, because it's not something you would have to know to write simple programs. It's more about like the inner workings of how the language functions underneath. So even though simple types are not objects, we can access their properties and perform methods on them. And so before I explain the mechanism underneath, I will talk a little bit about those properties and methods. What are these? Well, property is like a sort of information. So it's like an information about the value, like a sort of description. And method is an action, so something you perform. So you can say that property is like an adjective, and method is like a verb, because something is happening, it's an operation. And here I've got two variables. One is a string, and score variable is a number, 12.55. And so for instance, text length, this is how you can access its property. So text is a string, you put a dot and the name of the property, and you can retrieve an information about how many characters is in that particular string. So if I put here, if I copy this, text length, and paste it in the console, it's going to print out 9, because this should be 9 characters. Let's check. So I've got 1, 2, 3, 4, 5. Empty space is also counted as a character. 6, 7, 8, 9. And if I add like some new text and now check the length, it's going to print out 13 because I've added 4 more characters. So this is like, as I said, retrieving an information about the value. And the other thing, another example, text, and in square brackets I put 2. This is like kind of like me saying to the program, I want to work on text variable, and this is the notation to get the character at the given index. So I'm saying that I want to get second, or actually third character, because we start from count from 0. So we'll go 0, 1, 2. So I would say I want to retrieve m. Is here I have 2. Third character at index 2, starting from 0, 0, 1, 2, and it's going to print out m. If I'm going to change 2 to say, let's say 1 or 0, because we start from count from 0, it's going to print out s. So as I said, property is like an information about the status or state of our value. Something describing it. And methods are actions. So we have few listed here. In every single, like a different value will have different characteristics. So for instance, string has different methods than a score that is a number. So strings will have different methods than numbers. For instance, you wouldn't do uppercase on the score because numbers cannot change their case from small to capital letter. So just gonna do this one first to show you how it's done. I'm gonna paste it in the console. I've got text to uppercase. So basically I'm taking my variable text, this value that I assign to it, some new text, and I want to change all letters to capitals. So go to uppercase, and it's going to print out some new text, now all in capital letters, because that's what I communicated to the program. And so very important, when we talk about methods, they don't change the original value. So if you check text, it's still the same. So it's got all small letters. It produced the result, but it hasn't changed the original value, the default that I've assigned at the very beginning. And the other thing also that you have to remember is that methods are signified by those braces here at the end. It's like me saying to the computer, I want to do this. So as you can see, this is the exactly same thing as below without braces. And if I paste it in here and hit enter, I'm just going to receive an information about what it is. So F informs this is a function. This is the name of the function to uppercase, and it's got some native code because it's built in the object. We can use it. It's available to us. It's like a resource that whenever we need to change to uppercase, the code has been written. We don't need to write the code again, even though we could. We can just use it whenever we need it. So very important, if we use method, it's a method, and those empty braces at the end, that would signify that I want to execute the function. Sometimes a method inside the braces can receive an argument. And look like this, there is something inside that we work on, but not necessarily. For now, I just need you to remember that it's going to produce a new value. I would not alter the old one, and that we cannot forget about the braces at the end, because this is just going to return like an information, like just like we had with the property. So it's not going to, the action is not going to be performed this way. One other thing worth mentioning maybe at this time is that functions and methods are slightly different, even though they're used interchangeably, but methods are already built in the object. Cool. Different method for a number. So for instance, to fixed. And what it does, it would just round the number. So it would take score that I defined at the very beginning, go variable score with the value of 12.55, and it would round it up because it's like it uses the principle of the mathematical operation. So if it's 5, it would round it up 55 to 13. And this method can receive an argument, and the argument would specify how many decimal places I would like to be included. So if I put 1 decimal place, it would round up 12.55 to 12.6. If I specify that I want to have 2 decimal places, it would leave 12.55 because 5 is right in the middle. And if I do 3 decimal places, it would add 0 to it because I want to have 3 decimal places. 1, 2, 3. So this is an example of how you can use an argument inside the braces. And one other example of a method would be, again, we're coming back to text. And this is an index of, also taking an argument. This argument sort of necessary for us to be able to use this method. So referring to text, I'm saying I want to know at what index is letter S. And S is the first letter in the string, counting from 0, so it's the position 0, and it would return 0. If I change S to something else, for instance T, it would say that it's in the position 9, and it would take that first T from here. If I wanted to know at what index is a letter or a number 7, we do not have 7 in the text, so it will turn -1, suggesting there isn't a character that will indicate it. So -1 means that there is no character. And it's going to be useful in practice when you do validation, and some of the programs or tasks later on. It's actually a very, very useful method. And so, as I said, what we need to remember about is that methods will produce a new value, whatever we ask the program to do, but these won't be stored anywhere because the old data is not changed. It remains the same. So if we want to store it somewhere, we would have to assign the new value to a new variable, so as in here. So I've got now a variable new text, and we set that the old text variable we want to change to uppercase, and so the new text will produce now some new text all in capital letters, and it's storing the new value. So if we want to store this new value somewhere, we need to create a new variable and assign the new value to that new variable. Same goes for a fixed number. Fixed number is now storing 13 because it was score to fixed, so we rounded up 12.55, but the score itself is still storing the old value. Now the main subject of this material. So if it said that only objects have properties and we can perform methods only on objects, how is that possible that we take that simple value and we access its length, or we can change the text to all capital letters, and it's supposed to be reserved only for objects? So this is where I'm taking you out of your comfort zone, because it's like, this is kind of knowledge that you don't really need to be able to write code or write working program. But I always think it's best to know that there is a mechanism underneath that is responsible for something, and it's like also not going into loads and loads of detail about this, but just so you know that there is something happening underneath, and not arguing that simple type is an object, because it isn't. So simple types have no properties or methods, but we can still access its properties or perform methods on them. And here is like a kind of visual representation of how it could be done, because we don't know how it's implemented underneath, but it's just, I'm going to take you through the steps how I imagine it to be, or how it could be done. So for instance, we create a variable name and with the value of a string Lucifer, and then we want to access its length. So we type name length, and it would return 7 because Lucifer has 7 letters. So the engine does something like this underneath, that it would create an string object. And I know this seems like, whoa, what's that? Because we haven't discussed it yet, and we will when we talk about object-oriented programming. And for now, I just want you to kind of get used to this new structure, and I don't expect you to memorize any of it. It's just something to get a little bit more familiar with, and maybe at a later point it's going to be easier to understand if you already had like little bits and pieces mentioned about this. So underneath, in this fleeting moment, our simple type is kind of changed into an object. So there's a thing that is a constructor and a keyword operator in here that can be used to create an object of certain type. So here I would imagine that the computer or the program takes the const name and creates a temporary variable taking this keyword new string spelled with capital S, and that signifies that it's a object of that type string, and as an argument we'll take name, meaning our variable, and perform, or in this case access its property, but as an object, as if it was performing it on an object type of string. So if we try accessing our name temporary variable and its length, it would produce the same result. So it gives us 7, and then it would basically disappear. So it would do this magical transformation in that fleeting moment, fraction of a second, that would change into an object and then perform whatever we needed to perform, and then it would disappear, going back to its original form of a simple data type const name Lucifer. But again, this is just a visual representation of how it could be done underneath, because we don't know how it's implemented. But we know that simple types are not objects, and only objects have properties and methods. So we need to memorize that it is an underneath process mechanism that would change and transform the simple data type, wrap it in an object data type, and produce the result, and then go back to the original form. And that all happens so quickly that, again, we don't actually need this knowledge to produce fully working code, but it's definitely worth knowing. And it could be one of the questions at the interview, so they like to be tricky. Summarizing. If we call methods, or we want to get the content of the property, then in the background a temporary object, because it's like just a temporary mechanism of the given type, is created, which kind of wraps our simple type until it reaches the property or calls the method. So this is happening, then disappears and going back to original form where it's just a simple data type. But in the meantime, it has been for that fleeting moment transformed into an object. And since we have already mentioned those few things as an object of a certain type and the keyword new operator, then I'm just gonna mention those few other things, but do not get frightened and don't feel overwhelmed, because it's just for the purpose of like, okay, it's there, something like this exists, but you don't need to worry about this just yet. Because we can create objects ourselves, and that would be the syntax for creating your new object of a string type, or of a number type, or a boolean type. And the result would be pretty much the same, but pretty much not exactly the same. And so that I don't know anyone who would do that instead of creating a simple data type with the value of a string, rather than creating a variable username, a new string, and giving it as an argument Chloe, because it has its downsides. One of the downsides would be that, for instance, we got to know comparison operators. So if I put username equals Chloe, then I would receive true. But if I try doing the same thing with the exact comparison operator, that, as you remember, it has to have both the value and the type exactly the same, it would produce false. And it's because type of username is now an object. Username 1 that is storing exactly the same value, which is Chloe, would give us the result of a string. So as you can see, everything has its downsides, and this is not the most effective way of producing an object unless you need it. But this is a different story, and we'll get to that at the right time. And another one, for instance, if you take that variable female and I want to say new boolean true, it would, whatever the value I'm gonna put in here, whether it's true or false, it's always going to be true, because the type of object is always going to produce or give the result true. Yeah, every object is true. So it doesn't work with booleans, because the main purpose of having a boolean is whether it's true or false. That's the flag. It's either true or it's false, and we cannot have the type of object always having true. If we wanted to produce a validation, it would always give us the same result of true, because it's an object. And if we wanted to have another kind of validation and check whether it's Chloe, we wouldn't know, because the username here is an object, and it would kind of like give us not the expected result. And so I mentioned this, and this is like beyond what you needed to know at this point. It's just for you to get kind of familiarized with the syntax. This is the syntax to create an instance of an object of a certain type. And once we get to it, everything will become clear and you'll understand how it's done. For now, just something that I thought was worth mentioning. Our first simple data type that we will talk about in detail is type number. And so let's dive in right away. How do we create a type number in JS? Very simple, very easy, because there is no specific literal. It's just when we assign a value to a variable and we put any digits, then we know that we've created a type number. So this is the literal for creating a number in JS. Unlike many other languages, like for instance in Java, when you create a variable, when you declare a variable, you already need to know that it's going to store a certain value. So for instance, if it's going to be an integer, you would have to specify an int. And then the program expects that specific data type to be stored in that variable. And in JS, since it's dynamically typed language, we can store any kind of value in any kind of variable. So it's dynamically typed when the program is run. And so whether it's an integer or a decimal, the type of will produce the same result. So it's a type of number, and the same thing is going to happen if I check the type of my decimal example. Here also number. Regardless of a whole number or a floating point number, in JS always a number. As in the world there are many numeral systems, so are in JS. And so for instance, we have a hexadecimal system, which we are probably familiar with since we all had something to do with CSS at some point in our life. And so my hex number from here will stand for 255. So 0x is the prefix that is needed in order to inform the interpreter that is going to deal with the hexadecimal value. We also have an octal or binary. Binary is when you only use either 0 or 1, so only those two values are allowed, and the prefix 0b. If I uncomment this and save it, this value from here stands for 829. We also have a thing called scientific notation, which is signified by this letter E. So this 5E2 will produce result of 500. And in simple way to explain it, it's like as if we worked with the number 5, and then 2 in here means there will be 2 zeros. But it's a little bit more complicated, so it's like as if we said we work on 5 and we multiply by 10 times 10, because it's a 10 to the power of whatever number we're gonna put in here. So it's 10 times 10. Right, 10 times 10, it's 100, times 5, 500. So 10 to the power of 2. Cool. If we put 4E, 4 is going to be 40,000. 4 and 4 zeros. Comment this out. As with any type, we have specific methods devoted to that data type. And so I've created the variable new number, which is storing a value of 123.45. One of the many methods available to be used is toFixed. And so if I try doing toFixed on my new number, it's going to return 123. So it's going to always try to round the number, and depending on what number is found, so if it's 4 in here, it's going to round it down. If I change it to 5, it's going to try to round it up. So I'm saving the program and I'm executing my method. So it's now changed to 124 because it's been rounded up, because I changed the number here. So from 5 upwards, below 5 downwards. To whole number, unless we pass a value here as a parameter. So this stands for how many decimal places we would like to include in our to fixed new number. So let's copy this, let's paste it. And so here I'm specifying, this is my decimal point here, and then how many decimal places after the decimal point I want it to include. So it's just 1 here, but if I change it to 2, you see that the value is changed to 2 decimal places. If I change to 3 decimal places, it's gonna adjust and add a 0 at the end. So the program will do exactly what it's being told. You can work directly on a number. It's not like you have to declare a variable and assign it with a specific value, like in here. You can work directly on a number. But if we do something like this, 123, and by a dot we want to get to our method to fixed, it's not going to be possible. And it's because the program, when we put a number and then a dot, it's like indicating that we want to put a decimal point and a fraction. So now the program expects this number to be a fraction. And so if we want to fix the problem, we just put a double dot, and then our method to fix is going to work. Or we can finish the number with a 0 and then put another dot. So this is now a whole number, and then we can work on it with the method. But the fastest way is double dot. What we need to remember about if we work with numbers and methods, so for instance, this method now is going to return a string. So all those values returned, these are no longer numbers. Now they are becoming strings. So if I do type of my new number fixed, the type of indicating is that it is a string now. So if you're working with those and you build some programs, it's always good to remember and bear in mind that your new value is now no longer a number, but it's becoming a string. We also have an explicit method to string. So when we actually strategically want to change a number into a string, so there is a method to string. So again, I'm working on my new number, and I'm gonna clear the console. I'm gonna put new number to string, and you can see that it's now wrapped in single quotation marks, meaning it's a string now. If I do not pass any value here as a parameter, it means that I want this new number as a string to be represented in a decimal system. If I put a number 2, it means that I want it to be represented, my string number, to be in binary system. So again, if I wanted to change 255 to string and make it hexadecimal, so I put 16, and this would produce FF, which in CSS is white. Cool. And again, remember, working directly on a number requires us to put double dot, because otherwise our method is not going to work. We also have a method called to exponentiation, which is to the power of, and so our new number to exponentiation will be here. It's, as you can see, our scientific notation works. This is E stands for scientific notation, to the power of. And here briefly mentioning about the order of things that are happening. So if I do this type of, a new number and the new number that I'm working my method on. So it's important to know that firstly, this value is going to change, and then the operator type of will evaluate this as a whole. So not type of a new number first, but a new number to exponentiation is going to be executed first, and then only then the type of will evaluate its type. So if I was to compare those two values, you could think that the new number is going to be changed into exponentiation, and then it's going to compare to a new number and only then change to exponentiation, but that's not the order in which it is happening. So firstly, this is going to, those two operands, those two values will be converted to exponentiation, and only then the comparison operator will work. So these will evaluate to true because these are the same. So the order in which it is happening is pretty important. Now functions. Functions are interchangeably used with methods but are slightly different. So anyway, in your career as a web developer, you will just use it naturally and you won't even think about it anymore. Now it may seem a little weird, like why here I'm working directly on a variable and here I'm working on a number here and then passing my variable here as a value. So basically number is, this is an object and it's a function. And it's got its own methods that we can access. And then we can, for instance, evaluate whether this value that we are about to pass here as an argument is an integer. So decimal example that we've created before should return false because it's not a whole number. So this will evaluate to false because it's not an integer. Number 100.1 also not an integer, so it will also evaluate to false. No surprise, hopefully no surprise there. An integer example that we've created before will evaluate to true. Our integer example stands for 100, is storing a value of 100. 28,001, it's a whole number, so it will also return true. So that is a function we can use to check whether a number is an integer. If we create an integer example too and try to be like, I don't know, tricky, and we introduce the decimal point and then add 2 zeros, the program still knows this is a whole number. As long as there are 2 zeros and not a fraction, it will pass as true. So you can check and it's true because 100.00 is still a whole number. We can also check whether a number is complete, whether it's finite. So for instance, number 2 would return true because it's complete and it's finite. The values that won't return true on finite is not a number and infinity. We have infinity on plus and we have minus infinity. And so, for instance, this next example here will produce result false. And this is because JS has its limitations. So infinity stands for a range of numbers that are inaccessible. We cannot access them. We cannot reach there. And so the smallest and the maximum, the biggest number in JS is represented by this value. So it's 1 and 308 zeros after that on plus, and the same happening on the minus. So these are like the maximum and the minimum numbers that we can access, and anything beyond that will be inaccessible, and it's going to be defined by an infinity. So hence 1e400 is beyond our reach, so it's infinity and it's not finite, so it's false. We cannot reach there. Number is finite. 3e300. It's true because it is within range, so it's not an infinity. Those funny numbers in JS, which is not a number, this is the value of the number type. So if we check type of none, it's going to return a number, even though it cannot be recognized as a value of a number. So it is a type of number. Again, the program doesn't know what to do with it. So if we try multiplying 3 by an apple, we cannot multiply apple 3 times, because the creators of JS didn't think that this would be a good way to, like, for instance, print out apple 3 times. And so this has never been introduced. So this is not a number, because the interpreter, when it sees 3 and the multiplication operator, it will try to change that string into a number, which is impossible, and it will produce not a number. And infinity, apart from when we try reaching those inaccessible range of numbers, we will also receive an infinity if we try dividing anything by 0. So 4 divided by 0 as an infinity. Whereas at the same time, infinity is a type of a number. Other ways to create a number, but this is going to be an object type number and no longer a simple data type, is by the use of a keyword new and the constructor number. If we do not pass anything inside here, any value inside the parentheses, it's going to return 0. So number object is an object storing a value of 0. You can see curly braces, so you know it's an object, a number spelled with a capital letter. So for this, you'll have to know which values are evaluated to false or which ones are evaluated to true. So for instance, false is in JS is going to be the same as 0. A true is going to be evaluated to 1. And just so you have evidence, proof that is true. So if I checked number object to its value and I create a new number with the value of false, it's going to produce a number 0. If I change that to true and save it, and now try accessing a number object 2, it's going to return 1, because true evaluates to 1. If I try typing any string in here, and blah, save it, it's going to evaluate to not a number, because a string, when the interpreter will try converting blah into a number, it will meet an obstacle and it's impossible. So it's going to say, okay, I tried to change it into a number, so I found a number because I can see that you're trying to create a number here, but it's not a number. If we pass a string of numbers, it's going to return the same as if we pass just a number. So this and this will produce exactly the same result. Number object 3, it's a number, and number object 4, also number. So this and this will produce the same result, whether it's a string or just a plain number. Right, arithmetic operations. So I hope you remember our modulo. So modulo stands for how many times you try to do a division operation, and then what is the remainder of that operation. So if you divide 20 by 2, you will have no remainder. So you can fit into 10 times into 20, and there is nothing left over. If we do 20 divided by 3, it will be 6 plus 6 plus 6, it's 18, and there will be a value remaining. So it's going to be 2. Save. You can see line 79 is returning 2 because that's the remainder. If we try getting a modulo 21 of 20, it's going to return 20 because you cannot fit in 21 into 20, not even once. So it's just going to it's going to return the whole value because you cannot divide 20 by 21. Let's say, well, you can, and you're going to get a fraction, but that's how it works with modulo. This double multiplication stands for to the power of, so it's exponentiation. So it's as if we said 2 times 2 times 2 times 2. That is 256. 2 times 8, that's just a simple multiplication, 16. And 2 divided by 8 is 0.25. Sometimes at school we are using just a colon, so this is not a way to do it in JS. We have to use a / if we want to divide a value by another value. And these are examples of binary operators. So we have our arguments, which are in this case operands, and in here in the middle our operator. Implicit, or in another word, automatic conversion of a number to a string, or a string to a number with different operators. So the addition operator, unlike other arithmetic operators, will try to produce a string. So we'll take the number and turn it into a string. If we do this, we will receive a string of 2020. On the other hand, if we use a different arithmetic operator, in this case multiplication, you will receive 400. So it will always try in any other arithmetic operator, change the data type into a numeric data type. So it's going to turn the string of 20 into a number, and it's going to do 20 times 20. So this is done implicitly. So we are doing some operation here, but we don't actually say to the computer, okay, look, I want to get a number here, or I want to get a string. This is something you need to know about, be aware of, but this is happening underneath, and the engine is doing it for us. But there are ways to do it in an explicit way. So explicit conversion using this function from here. Number, any value that we pass here, we will try to convert into a number. So this is simple because it's a string, but it's a number inside. So it's going to produce 210. True will evaluate to 1. As mentioned before, false will evaluate to a 0. An empty string is a falsy value, and it will also evaluate to 0. So if we try to convert an empty string into a number, we will get a 0. And anytime we try to make a number out of a string that is actually containing some characters, we're gonna get a not a number, as in here. Implicit conversion usage. So that's certain tricks that we can apply at work. If we don't, for instance, we don't have much time and we want to check something very quickly, like I wouldn't recommend doing it at like the programs that are going to production. And then if we did this, we would get a number. So any string that we multiply by 1, it's gonna give us a number. What do you think should happen here? I think this is like a double tricky, because normally a plus operator will change a number into a string. So as I said, I think this is double tricky because you'd expect it to change into it. You would expect not to change it, because every time we're using a plus, the value will become a string, but in this case this actually becomes a number. And if we do a number plus an empty string, this actually works the opposite, so it will produce a string. So everything is tricky. When we want to change the number type to the string type, we have two ways of doing it. So working directly on the number, like with the method to fixed, remember to use double dot, and method to string will change it into a string, or you can use a method string, and inside the parentheses we're passing the value that we want to change into string. So this is also going to be discussed when we talk about a string. So it's like approaching the topic from the other side. Most often we convert referring to a variable, not a number, directly. And yes, we normally would not work directly on the number, but we'll actually put some variable here. Called next thing. Next thing is pretty useful because it's a parseInt method, and this is something that you're gonna use, maybe not definitely because it depends on the type of work you do, but this is very common. This is used frequently in the programs. So parseInt will allows us to change a string into a number. So we parse through the first argument and we change it into a number. And so for instance, when there is a form online or something, this is pretty useful. So to parse through the value passed by the user and then extract the number. And so it can receive two arguments. And the second one is specifying what kind of notation or the neural system we want our value to be represented in. And so for instance, here we are passing through 20, and this stands for a decimal notation. So normally if it's a decimal notation, you don't have to use the second argument, and this is the way you will most frequently see it, because we normally want our values to be represented in a decimal notation, and so we don't use that second argument, but we can. So if we console log the result of this, we will see an regular 20. 2 stands for a different system, and 16 stands for another yet, which we already talked about. So it's gonna result in 255 with the prefix here 0xFF. The program goes through this, parsing through the string of characters, and it can recognize the value of 255 in the hexadecimal. So this is also a no-brainer. It's going to produce 100. This is going to produce 200. This we have already seen, 255. And parse int 222 ABC. So as long as the number comes first, the program will pass through as long as it can see the numbers and the remaining, so the ABC is gonna be left out. You can see it's only 222 returned without the ABC. But if we put A at the beginning, then the computer will, the program will get confused and say, okay, this I tried to make it a number, but it's not a number because it encountered a letter first and it expects digit. Or if we put something in the middle, then it would parse as long as it doesn't encounter that letter here. Cool. Parse int. If we work with a floating point number, then it would completely cut off whatever is left at the end. So it's always gonna return the whole number. If we want to keep the fraction, then we have to use a different method, parse float. And parse float accepts floating point numbers, and so it's gonna return the whole thing. And again, if we do parse int 200, parse int 3, then those are operands again, and firstly this will be executed. So this becomes a number, this becomes a number, and then the plus operator works. So it's at this point when the operator works, it works on two numbers and not two strings. So firstly this is executed, parse int, and only then those two values will be added together. And we get 203 rather than 2003 as a string. Cool. Use the built-in math object. So there is this magical math object, like the mother object, and it has many methods that we are going to use. And so for instance, we have a method, like with the number, so we capital letter math dot to get inside, and we can access any method it has. So just to be sure that you can see it, got math, and you can see that it's got its own methods inside, all mathematical. So if I do math round, it's gonna round up depending on the digit it finds, either up or down. If I do math floor, it will always get rid of the fraction, and it's more common than you would think. So it will always return the whole number, but down, not rounding up, not paying attention to whether it's 5 or it's 4, and it's always gonna get rid of that fraction from here. And everybody's favorite math random. Math random, also very something that we're gonna use a lot, and it's like returns a random number. So like if you want to create a game and you have to like kind of pretend this randomization of data, some numbers have to be chosen at random. So this is the method that you will go for, and it returns a random number between 0 and 1. So 0 included, but 1 is not included. So something between 0 and like 0.99999 is the maximum. Reminder of recruitment and assignments. Yes, something we already talked about. And then revision is always good. So we've got active users variable with the value of 1. If we do now active users plus plus, actually it has to be saved. Let's check. Active users is now 0. If I do active users plus plus, it's going to print out 0, because firstly it's going to print out the current value, then add 1, increment by 1, and so actually active users value is now 1. But this plus plus here works this way, that it's firstly going to return the value of what it found, the current situation, and only then act on it. Active users plus equals 7. Again, this is the same as if we said take active users, whatever is the value now, and add 7 to it. So it's a short way of putting this. And trivial meaning, like some curiosity, small thing, something that is not actually something you have to remember. But I always found it interesting. So undefined plus not a number will produce not a number. Infinity plus undefined, also not a number. Infinity minus infinity. I wanted this to be 0, but unfortunately when you're in infinity, you don't know how far you've reached. So one infinity doesn't equal the other infinity. Hence, it's not going to produce 1. It's going to be not a number. If you do infinity minus 100, still infinity, because we never knew where we were in this infinity. 0 plus now is going to be converted into 0, so we're going to receive a 0. There you go. And if we try dividing 1 by an infinity, interestingly, we'll get 0. So I will see you in a bit talking about the string. And for number, that's it for now. Thanks.